Hello. At this point in your statistics class, you've talked about how to find the mean of a sample set or a population set, any kind of given data set. And you've also probably talked about how the mean is not always the best representation of the data. You can have two data sets with the exact same mean, but when you look at the data sets, you can see that they're very different set of numbers. Okay, their variation, how far away they are from the mean, how spread apart the data is, all that can vary, even though the mean can stay the same. So this is where finding the variance and standard deviation comes in. These two values that we're going to calculate are going to tell us a little bit more about the data set than the mean alone can do. So you see I've made a table over here. This is the kind of table you want to make every time you're trying to do a variance and standard deviation by hand. This is what you want to set up. Okay, a lot of times there's a formula. Okay, if we look at what variance, if you look in a textbook, it says the variance, which is that symbol right there, sigma squared. It says it's a formula that looks like this. Okay, this is for a population. If it's for a sample, you divide by n minus 1. But in general, this is our formula for variance. Okay, so a lot of people that are new to statistics look at that formula and try to plug stuff into it and try to get a variance out in one step. As we look at this table over here, you're going to see where this formula, where it comes from. It's not something that I can just plug into. I have to find a bunch of other values to be able to use that. So just kind of keep that one in the back of your mind, but we're not going to use it the same way we use some other formulas. Okay, you'll see how it kind of works itself out. The first thing that we do need to do in order to find a standard deviation or variance is actually what we're going to find first, is we do have to find the mean. Okay, so the mean of this data set is just a sum of all the values divided by n. So this mean comes out to be, for this set, if you calculate, it's 41.5. Okay, so again, like we said, 41.5. So this happens to be salaries in thousands for all new hires. All new hires, I'm just going to highlight this word right here. So all means that it's safe to say that this is a population. Okay, so when I go forward, we can say this is a population since it's not a sample of new hires. So this is saying that on average, these new hires make $41,500. That's the average of this set. So let's figure out some more things. So the first thing we would do, okay, I'm going to blow up this table a little bit more so we can concentrate on just that part. Okay, so what I did was I took each of my data values, and there was 10 of them, and I put them in a column. Okay, what I'm going to do is I'm going to figure out how far away each salary is from our mean of 41.5. Okay, so that's what our deviation column is. So our deviation is we take each x and we subtract off that mean, and we see how far away is each of these from the mean. And we need to include a sign. Okay, so in general, so when I'm doing this salary, this 41, my mean's 41.5, this data value is 0.5 below the mean. So I'm showing that with a negative. Okay, 38, if you did 38 minus 41.5, this one would be 3.5 below the mean. Okay, this one would be 2.5 below the mean. Okay, this next one, 45, would be 3.5 above, so I'm writing that as a positive. This would be 5.5, that's supposed to be a 5. This would be 0.5 below the mean. This would be 2.5 above. This would be 0.5 below. This would be 4.5 below. And this would be 0.5 above. So that's what my deviations are called. Okay, that's how far each x value is from that mean of 41.5. So a lot of times our next logical step we would think to do is to figure out how far away, each thing is from the mean, is to take an average of this column. But if you try that, if you try to sum up this column right here, if you try to sum these up, you're going to get stuck every single time. You're going to come out to be 0. Okay? The reason for that is because the mean is exactly, what we say is the average. So you're going to have equal amounts above and equal amounts below if you're talking about how far away you are the mean. So when if I try to average that, when I sum it, I get a 0. So we don't want to do that. I mean, you can do that to check, but this is not going to lead us to our variance and standard deviation. That's where we have to find something else. Okay, so our next thing to do, the reason this is summing 0 is because we've got equal amounts positive, equal amounts negative. So they're just kind of canceling each other out. So that's where this squares column comes in. You know, if we square a negative, we get positive. So we get to look at these deviations. If we look at them squared, then it takes the sign away. So my next column is going to be my deviations squared. Okay. Just move this up a little bit. Okay. So now I'm just going to take each one of these deviations, I'm going to square it. So the first one I'm going to get 0.25. And then I'm going to get 12.25. This is just the squares of those. Okay, so let me just fill these in. This one's 0.25, 6.25, 0.25, 20.25, and 0.25. Okay, so now, if I try to average this column, I won't get a 0 anymore because we squared them. Okay, and that's exactly what the variance is. So let me move this down a little bit so we can do a little work down here. Okay, so now, if you go back to where we were at the very beginning, I showed you that formula for variance. So remember my variance, the formula I gave you, well, this is the symbol we use for variance. We're doing population, okay? If we were doing sample, we would use f squared. So my variance is the sum. If we look at this formula, we can see exactly where it is. Okay, so I'm just going to circle. This part right here is this column that we just found. So what it's saying is to sum up the squares, sum up our squares, and divide by n. That's going to be our variance. That's going to tell us the average of the squares. Okay, so let's do that. So if I do that, I calculated this before, and the sum of the squares column will come out to be an 88.5 divided by 10 gives me 8.85. Okay, so that's what my variance is. So my variance in this one equals 8.85. Okay, here's the first thing. Okay, so if we're comparing two data sets that have the same mean, if we then compare their variance, if one has a larger variance, it means that the data is more spread out than if one data set has a smaller variance. It means my values are closer to the mean. But something that's even more appropriate to find, and it tells us a little bit even more than that, is our standard deviation. Okay, so let me move this up a little bit. Okay, so there's our variance. We always find that first. So now our standard deviation, if you look in a textbook, okay, the symbol is just sigma. Okay, so there's so many different ways to write this. Okay, sigma, first of all, it's a square root of sigma squared. Okay, which really just means it's the square root of the variance that we just found. Okay, so you're also going to see it written like this. Okay, so that formula is another one. We can't just jump right in and use that formula. We have to find the deviation. Then we have to square it. Then we sum them up. Then we divide by n. Then we take the square root. So don't forget that this right in here is something we already found. That was my variance that we already found. Okay, so at this point our work is already done. Okay, so my variance in this case is going to be the square root of 8.85. Okay, so this is going to be approximately, if you do that out, it comes to be approximately 2.97. Okay, so that means that on average, so that's my standard deviation. That means on average, this is the amount that each data value on average deviates from the mean. Okay, so this means that each salary deviates almost $3,000 from that mean of 41.5, which was 41,500. So those are your steps for finding variance and standard deviation. You can also look into calculating these on the calculator, but this is doing it by hand.